Recording is
Good.
on.
Very well. So, welcome to the office hours number five, and our second session dedicated uh, to the. Let's see, we're just doing the backup here. Second session dedicated to the project presentation. So, I'm looking forward to see all of you presenting your projects. Before we start, just wanted to emphasize again, I'm so grateful for many great projects coming in. It's been um, it's been very motivating, very exciting to see a bunch of cool stuff. I want to apologize again for not being able to review all of them in time. It's been a specifically busy cohort this year, so I didn't have time to go through all of that, and I'm still in process. Um, Today we have many people signed up. There is 14 comments under the issue, and we can fit maybe like 6 people into one call. Depends on how long the presentations will be. So I see that you got excited and signed up to present, but guys, that's why we had the opportunity last week. We only had 3 people there, and now we have 14. So the timing there isn't really ideal. Now we have too many people sign up for now, so we are definitely not going to be able to go through all of that. I will, based on like the maturity of the project and the order of the issue in the issue, I will call you to join us and present. But I believe that all of you that signed up should be ready. So from the beginning of the issue here, I think we could start with Arsh if you are here and ready to present.
One second. What?
Yeah.
Hello, yes. Actually, me and Ash are going to present together.
Yeah, perfect.
Okay, I'll share my screen just a second.
Yeah. Go ahead, share your screen and show us what you got. And because I saw well, thank you so much. Ash. I see that some of you maybe signed up prematurely. So again, we have too many people signed up anyway, so we're going to take all of you
Is
here.
my screen visible?
Yes, all good. We can see
Yes.
it. So
Okay, so
the stage is yours. You can go ahead. I hear both of you guys, and who is not speaking should mute the mic. So you see guys.
I am going to start first.
Go ahead.
Okay, okay, good. Um, Hello everyone. My name is Parth, and me and Arsh are going to present together for 2 projects. And first is the SSC execution blocks, and second is the SSC query language. And our mentors are Tamagna and Eaton. Okay, so the figure which we see on the left hand side is the problem statement. We all know the the disadvantages of the current Merkle-Patricia trie, and like we know that everything is packed into the MPT, and even to prove a single status or log field, we have to like traverse the whole tree. So that's what Pureth is trying to counter. Uh, the figure on the right hand side, this is the prototype which we are supposed to make, and the tree is deterministic, and there is a G index along with the siblings, and to prove something we got to provide the G index along with the siblings, and it the proofs are not really that much bulky. um, the scope of the project, we are not targeting a full EIP 7807, which is the parent EIP for SSG execution blocks. The things which we are targeting are these. First of all, I'll be starting with withdrawals. Why withdrawals? Because it is the smallest and the least compact of out of all three, and it will give me an idea of the SSD conversion, and how to do the root computation. and the deliverable for this phase will be a root computation checked. Okay, the second stage will be receipts and logs, and this is the part where the three purest projects of this cohort they come together, and the logs part, it is a separate project. As we all know, it is the trustless log index, and I'll be working majorly on the receipts part, and I'll be like computing the routes for the receipts part, and the deliverable for this phase will be a log address verified end to end. Uh, just a small note here. I have to like discuss with the fellows working on the TLI project about the shared scope that we'll work on related to the TLI project. And after that, the extension work which I think I'll do later on is the transactions, and this is not really in the scope now, so we'll skip it for now. And these are uh, the areas which I'll be working on. Withdrawals is pretty much a single grade code, and the code lives in the Ret Ethereum primitives crate. So that's where I'll be working on. Receipts is basically a multi-crate implementation. Like the types live in Ret Ethereum primitives. The receipt building is the EVM part, so it lives in our EVM, and the historical like receipt lookup which happens, it happens under the storage trade. So this particular part, this spans multiple grids, so that's why it is going to take a lot of time. And after that, transaction, as much as I have researched for now, there's a model named Ethereum TX envelope, and I can't really comment that much about it, so we'll move ahead. And after that, how we are going to start our work. So the three Purest projects, we will sit down together and we'll discuss on a schema, like how are the SSD structures are going to look like, and this right here is a demo like implementation. It's not final as of now. Like how are the receipts are going to look like, how are the demos will be looking like, and after that, all the three projects are going to branch off and work on their specific implementations. The figure on the right hand side, it is specific to Arsh's domain, so he'll be covering it up next. And after that, this is the point where my project will like hand over the torch to Arsh's project. Like I said, we'll be agreeing on an SSE object, and I'll compute the root, and after computing the root, I'll be handing it over to Arsh via a root provider. And uh, for the initial stages, the root provider is going to be a dummy root provider, and after my work is finished, after the root is computed successfully, that dummy root provider is going to be replaced with a Reth root provider, which Arsh will use to compute the proofs, and after that, I'll let Arsh take over and explain his part. Thank you.
Okay, so hey, I'm audible.
Yes.
Path, I'm audible.
Yeah, yeah.
Okay. Okay, so um, this is the RPC side, yeah. So this will be the part like will ask Reth, how someone will ask Reth for proofs, right? So on the left you can see is the normal receipt request that we already have. We want to keep the same flow when someone needs to ask for a proof, and in the middle, the receipt responses like just gets one extra SSD proof section, and the normal fields stay as the proofs come with them. And over the right side is a more specific query part, which is the Pureth query. So like when someone selects a block, an object, or maybe a path, so like an address inside a particular log, so that will be a specific method for it. So that will be the usual receipt flow, while both have a similar proof format. So this was about the query and proof part. Next slide, please. Okay, so this page is all about how the request moves. Okay, So like this basically this the flow that you can see in the boxes basically explains what happens when the request reaches reth. Like first the pass the with the RPC module which is present, the reth receive the request, and we can just use parser to break the path into field and list positions, and then the route provider will bring the matching SSD object and the route. So that is what Parth just explained. His side will connect with the mine side, and the query code then will go over through the object and find the value and figure out its position in the SSD tree, and that position will be the G index, the generalized index, and then the proof code will be helpful to collect the sibling nodes to check the root. So the bottom two things that are written, the red surfaces we build around a project abstraction. So the left side is basically what currently exists, and the right side is what we'll build around ourselves, because these are not the existing Graph APIs, right? Okay, next slide. Okay, so success. This slide basically explains what will be our first working result, right? So like before trying to support every receipt field, we want like one complete path which should work properly. So the checklist on the left that you can see is our definition of the starting done, that will say we'll take a known receipt object and ask for one log address, and then check the proof that rebuilds the expected route or not. And like if we change the value proof or route, then it must fail. And on the right is how both of us can work at the same time, the dummy route and the ref provider thing that Parth has already explained. So I'll skip with some time here. So the request does not change during that switch, but like considering the part where this works or not works, so then we'll move later to the path for transactions, anchoring, and CL support. That too we have shortly planned, but yeah, it is perfectly aligning with everything so far. Next slide, please. Uh, First vectors. Okay, this is basically the slide that is explaining how we test it. Like we'll keep a fix. We'll for sure for the starting we'll keep fixed examples, like where the object root value and proofs are known. So a separate verifier will check instead of trusting the code that has produced the proof. So that will be the basic fundamental principle for it. And the steel and kurtosis part, the steel, as we know, is the execution spec testing work. So if the matching pureth vectors will be available, then we'll compare the results with them. So for till then, we'll just use our saved examples. And the kurtosis part will come active after we complete the reth integration part in our roadmap. We'll basically run a local devnet using a modified thread and produce a block called both proof API and like verify them against the root. So yeah, for this cohort, our working with devnet path is will be like the target. So that was it about this part. Yes, next slide. Okay, so the roadmap part, yeah. So like if you put everything on the timeline, the first few weeks will be like for us to agree on the receipt schema that the part that path is already told in the first two slides, and then we'll go to the root provider and the test data and the verifier part. So like after that, both tracks will move separately. Parth will work on the withdrawal and receipt routes, and on my side, I'll work on the RPC and parser and the query flows and the further proof generation, uh, which will be first using the Debian backend, then will be replaced by the real integration that will happen between Barth and Mine project. And for the weeks of 14 to 17, we'll probably have both of our sites meeting inside Reth. So like we'll replace that dummy data and with the real receipt object roots. So we'll be able to complete run tests also. So and the last phase, I'll say that last phase is for things like we'll confirm later, like for more paths or transaction support or anchoring or CL support that we have also discussed with the mentor. Also, you can see in the green box there like it will be the basic result that we will want before any of those extra stuffs. The receipt log address will finally lead towards the SSD field proof against the produced red fruit. So yeah, I guess this was it. This was the complete plan from our side. Uh, uh, Now Parth and me will take the mic if any one of you has any questions or something.
Yes, thank you so much, Arsh and Part. It was great to hear both of you guys. Don't worry to be loud and have some confidence in the voice, so we hear you properly. But I think I understood it well. Guys, do we have any questions and comments? I see the Magna is here. Any thoughts? Oh, okay, any thoughts? Any questions?
Yeah, sorry about the voice. Also, we both are having fever, so we barely managed to come.
Well, sorry to hear about that. I hope you're
Yeah,
feeling
we
good.
fine. Don't worry.
Yeah, awesome. Well, do we have any questions? Any thoughts? Anyone?
Okay,
Okay.
so I guess this
Yeah, there is a question. Will this be using Bloom filters for logs or the newer A304 pattern?
I guess this is related to the TLI project, and we kind of we I scheduled. I asked for a call, like to the people working on the TLI project, and we'll like clear things up with them, and I think I'll have a better answer after that.
yeah, because I guess our project is not for the log indexing part, right?
Yeah.
So we'll just prove a log field after the like path is given. So like integrating that would be separate work, right? Yeah, sure. You can reach out to us. And if anyone
Like,
of you has any further questions, you can connect with us on Discord.
yeah, like there were multiple people working on the TLI, and like that's why I asked for if anyone, the guys who are working on that to DM me, and like like 3 or 4 people DM'd me after that. So we are not really sure what to do for the TLI part currently.
Okay, thank you, Prabhinash. Uh, yeah, I hope you'll be in touch with Vansh. That's great. Cool. So Avivansh told us that he cannot make it today, so we are skipping him, and we are continuing with Vivek. Vivek, are you here? I don't see Vivek.
Hello, hello.
Oh, oh,
Oh,
hey,
yeah.
here you are.
Oh,
Hey, man. So I saw your proposal. I have read it and did not post my review yet, but it looks good. So feel free to go ahead and present.
yeah, sure. Like my mic has some sort of issue, so if I am not audible at any point of time, please ping me on the message. I'll see that.
Yeah, you sound good.
So,
Yeah,
yeah. So I'll present my screen.
no worries. Yeah. Again, sorry I did not have time to properly review the proposal, but it looked cool.
No
So yeah,
worries.
go ahead.
So is it visible?
Yes.
So, hi everyone, I'm Vivek. So, my project is like bringing SHG education blogs to GAT. That's basically the EIP707, like the project that part discussed. So, yeah, I'm on the part pure red track, and basically my mentors are the Magna and Eaton for this. So, if I talk about the problem, I'll move faster here because it is already covered by parts. So, like right now, when you read anything from Ethereum, you basically trusting the RPC provider. Like today, our block identity is just a cache over the RLP encoded header. So basically, it's a plain hash of types. So what AIB it's 707 does is like it turns the block into a SSD container and make the block hash root of a Mercury tree over its contents. So like on it's a tree, a field of the block or like a fact that a given transaction or receipt is there, it becomes provable against the block hash like with just a few hundred bytes. So I am taking this project in Geth, so I was exploring the code base. So the thing is this: there is no HSC SSC execution block implementation going on or present right now in the CAD. What SSG is there is like three separate mechanisms that don't talk to each other, and none of them can do the progressive types that this current EIP need. So like also like this is my favorite part. There is a real command in the cat proposal right now, like from a code developer, like it says remove this when a SSD encoder runs. So the team is literally asking in the code for the thing that this project builds. So like there is one open SSDPR also, like the Magna pointed to me, it pointed me to it. Like it's basically a big draft VR from one of the core maintainers. Like the key, but the thing is key, it changes how messages are encoded in transit between the client. It does not change like what the block hash is, and it only uses static types. So like it's a different problem, but it's useful to me as a style reference for how the team write SSD code in Cat. So yeah, if I move to next slide. So yeah. So like these are the two things that basically helps me to solve the project. Like first one is the EIP 707 itself, which is about this is the EIP for this project. Like it got like in the June, it got reduced to a standalone style, like where transaction, receive and withdrawals are just keep their existing codings, like which means the block can be done first before any of the heavier object conversation works. So that makes the like core of the project a lot smaller. So, if I talk about the second one is like basically EIP 7688, like it's basically considered for inclusion in game strengths. So it's not like it got merged into the consequences specs, and it's been implemented across the conscience client right now. Like PRs are open in Prism and Lighthouse. I guess Losser and Nimbus already have this. So what that means for me is that like progressive SSG is coming to conscience side, and if it ends up in the fork, Gatlight has to verify it. So the engine I am building here has a possible user inside Get, even if 707 itself delays a bit. So yeah. So what I'll build is key like so here is the approach is like I build the engine first because everything else in the project depends on it. Like it's a new package for a token name like Core SSG, which is built in layers. I'll build in layers from bottom up. Like at the bottom, basically the codec, and then the from like converting the values to SSG types and back to the values back, like with strict checking on decode. Uh, Also then there is like then the part this is the part that no go library has like into like basically the progressive types from 7916 and we add like a different tree shape that lets the structure grow across fog without breaking existing proofs. And like on top hash tree root and basic proofs basically build like most of the stack is existing SSD spec, like the generally new like piece is the progressively in the middle. Now, if I talk about the blog part, like if you take a normal get block, today it gets has this casec and the stress exactly as it is. Like what I add is a second part that maps the same block into a 7807 container, basically the 18 fields and computes its hash tree root. And the mapping mostly uses what get already has, like transaction would go in as their existing bytes. So in my like in my committed scope, I compute the new root next to the existing hash. Yeah. So if I talk about the scope, so I've committed three things basically. Basically here the SSG engine, thus the that I have described. So we have to build the core. It is not something that we can wire up. So the 707 container where I prove the header assembly root equals the full payload. That's what lets a light guide compute the same block hash from just the header and validating those new routes against the real blocks from like different fork errors. Like the key point is here is that across all three get keeps using cassettes. I'm just proving the new routes are correct. Then also I also have a slash leader. Let's say if the things go well and good, if the project is developed before the time, so I'll take this stretch commitments. So basically the actual switch from cassette to SSD, then firing it into the engine API, then basically a small DevNet for testing, and maybe I can take the withdrawal conversation as a pilot. Also, let's move to the next slide. if I talk about the roadmap, like how I'm gonna move, so basically my roadmap also follows the same dependency order. The engine, then the blog, then the stretch stuff. So the thing I do, I would like to point here is basically the last column, the exit criteria. Like every milestone ends here with a checkable exit. So there is not something anything vague. Like it's like anything vague key. It's mostly done. So like M1 is done when the classic vectors pass on both hashing backends. M2 is done uh, when the progressive vectors are green and the refresh implementation agree with mine. M3 is done when the container reproduces its vectors and summary equals the full root under fuzzing, and so like so on. So this means at point I can actually tell whether I am on the track or not. So yeah, like for me, the success is like key. So like basically a solid groundwork that's validated against the official test vectors and the routes that I can actually demonstrate. Like basically concretely, the engine passes the full official test route and container reproduces vectors, and the 7807 route is computed correctly next to the real block hash across fork errors. So yeah, thank you.
Thank you so much, Vivek. Um, yeah, very ambitious. Thank you so much. So, do we have any questions, any comments for Vivek's proposal? Any thoughts? Anyone? Yeah, I'm just wondering, like, because you chose the get here, and like, how do you compare it maybe to other clients from the perspective that like get always chooses like stability and like conservative approach compared to like bunch of contributions and performance and so on. So like, how do you manage this? What gives you the confidence basically to be able to work on the get code base? How do you find the code base compared to other clients? Yeah, how do you feel about the choice?
Yeah, like basically, like before, I was going towards the red path only. Okay, because I was not sure like Gath would like to include this or not. So I was taking the red path then, but Parth was taking the same thing. So I have to pivot basically. So like Gath was something like the last option I have, and I talked with the Magna. Like I was not confident ki Gath this thing would land in Gath or not. So like Tamangna like gave me the confidence like yeah this thing will probably land there, and there is some sort of work also going by the core maintainers. So like this is what like a bit gives me a bit confidence for this.
Right. Thank you so much, Vivek. Yeah, awesome. Glad to hear. Okay, next up we would have Christian and Rahul.
Hi guys. Yep. Let me share my screen.
Yes, go ahead.
Cool. Can you guys see my screen?
Give me a second. Yes, yes, Fossil and Lighthouse. We can see that. Yes.
Awesome. Awesome. So yeah. So basically, hi, I'm Christian, and together with Rahul, we're presenting our project for the cohort and implementation of Fossil and Lighthouse, which we aim to do to make spec conformant and ready for interop, ideally. First of all, a bit of context. Why do we need Fossil? Well, while we remove the trusted relay in GLOAS and we enshrine the builder still can decide whatever transactions to include in a block. And that becomes a problem when most of the blocks are built by 3 entities. So that really becomes a censorship problem. In other words, Fossil is the way of the consensus telling the builder, hey, you cannot just ignore my transaction. So in terms of mechanics, how does it look like? And basically what do we need to implement is, as you can see in this diagram, we need to look on the changes added to the slot anatomy by GLOAS. So we will fit there. And essentially what Fossil introduces is this 16 validators inclusion list committee that each slot n-1 broadcasts a list of transactions, and these transactions must be included in the next block at the slot n. So when the payload is revealed, that payload is checked against the n-1 inclusion list transactions list. And it's very important to check if it satisfies or not the inclusion list, because if it doesn't satisfy that block will be orphaned. So this way, this becomes a consensus rule enforced by the consensus, enforced by the consensus node. So how would it look like in terms of present implementation? We were thinking about this, and the best way to split our work was to look at this in terms of two main flows. One flow is the production side of things, which includes productions of the inclusion list of transactions, and then the production of blocks, so updates on the block production side. And the other side, which Rahul will present more, would be receiving this inclusion list and enforcing the rule at the fork choice level. So regarding the production of the inclusion list, this would mean basically integrating, let's say, a core service here, which is an inclusion list service that will have to interact with already existing components that they will also be updated in Lighthouse, duty service, beacon node, and so on. And the goal for this one is to be able to fetch inclusion lists from the beacon node, then pack this transactions list, sign them, and then broadcast them back to the network on the peer-to-peer level on the inclusion list topic before the cutoff, as we saw in the previous diagram, the inclusion lists do. So that's the core of it, and that happens when the validator client is in this committee. So that's the production of the inclusion list side. Then we have the proposal of blocks at slot n. Here we also will have two cases that we need to handle. First of all, we need to handle the case when the proposer is also the builder. In this case, we need to integrate with the engine API and make sure that the slot n-1 inclusion list transactions are also included in the block payload. And in case of the proposer actually accepting external bids, we need to make sure that they check the inclusion list bits with regards to the view of the nodes regarding the votes that the inclusion list committee member had for the previous slot. And yeah, handling this logic would help us produce blocks that don't censor transactions. They also comply with this inclusion list satisfaction and won't get orphaned eventually. So yeah, that's the production side. I will let Rahul take the receival side of things as well as enforcement, and give a bit more details into how we plan to implement these flows.
Thank you, Christian. So yeah, so receiving inclusion lists. So the inclusion lists come in over the gossip throughout the slot. So the node runs a few quick sanity checks and verifies the signature, but the real gatekeeper is the store, and that's where we catch equivocation. So if a validator, tries to push two conflicting lists, they get flagged and ignored from then on. And anything that checks out gets relayed onward, and we mark it as timely if it landed before the cutoff. Next slide. This check happens at a slot later, as Christian already said, because with EPPS, the payload only gets revealed late in the slot at what's called envelope reveal. And so that's the first point where we can actually look at it. We basically ask the execution client, like, did you include the transactions this list asked for, and record the answer against the block. And the cool part is, like, if the answer is no, we don't really reject the block. It's still perfectly valid. fork choice just won't build on top of it anymore. So it ends up as an orphaned. And that's really the core idea of fossil. Censorship gets punished through fork choice, not through validity. And yeah, this is the whole scope. 6 pieces: producing the list, receiving, storing them, enforcing, block proposal, and networking around it. And we're not starting from scratch either. Like there's already a prototype branch we are using as reference and bringing up to the current spec as we go on. And we are shipping it as small incremental PRs. So each piece, gets a proper review and stacks on top of each other. The main challenges that we are expecting are like the spec is still moving as GLOAS and Heze is forming up. So we are like kind of building against a shifting target, so as to say. And for testing, like which has to lean on and an extended mock EL for now, since there is no fossil ready execution client to run against yet. So yeah, next slide, please. Yeah, thank you. This is roughly how it's paced across the cohort. 4 phases, starting from the foundations and building up through enforcement, block production, with hardening at the end. This is done in order to ensure that in each step something meaningful and functional is being created. The target outcome is a spec conformant implementation that is running cleanly on the Heze devnets. And if you got the room and interop against another client as a stretch would be cool. And yeah, that was it from our side. Thank you so much for listening, and we'd love to hear your thoughts or answer any questions.
Awesome. Yay. Thank you so much, guys. Thank you
Thank
so
you.
much, both Christian and Raul. Great to hear from you guys. Awesome.
Thank
Do
you.
you have any comments, thoughts from the audience? Yeah, I just want to say that it's really amazing to work on something that's actually scheduled for inclusion already. So like a proper SFI'd feature in a client. It's also a unique position to be in a fellowship to work on something that's straight up going to the protocol. So I wish you guys a lot of luck. I see you have a lot of courage to be able to work on this. So really appreciate that, and it's a feature close to my heart. I very much care about censorship resistance, so I'm very glad to see you guys working on that. It's really cool, and yeah, it looks really sound.
Thank you. It's
Thanks.
also really exciting for us as well. So we're really excited to start.
Yeah, definitely. Thank you so much.
Very well. Thank you so much, guys. Awesome. Okay, any other thoughts? Anyone? Okay. Is Sagar here? Do we have Sagar? I think I saw him leaving before. I think he's in the call. Okay, Steven, are you ready to present? Steve Milk. I see Steven in the call.
Sorry.
Yeah.
Sorry. Yes.
Okay, good.
Yeah,
Good.
let me share my screen.
Perfect. Awesome. Thank you so much.
Can I see my screen?
Yes.
Okay, cool.
Perfect. Yeah. Okay. Now we lost the presentation. Yeah. Now it's perfect. Yeah. Awesome. Go ahead.
Okay, so yeah, hi everyone, I'm Steven. I'm now working with Aragon team on this project mentored by Mark. What I'm building now is a snapshot layer components for Aragon's federated history network. And as you can see, this is actually a subtask of a broader proposal. Now let me walk you through why this matters and what the bigger picture looks like. So first of all, the motivation. Like after EIP44, most clients, all clients stop serving old chain history over P2P layer, and that leaves history data available only for archive nodes. And today, there's largely fall to a handful of volunteer murals, which bring centralization risk. So Aragon's answer is is trying to turn the history distribution into a self-certifying distributed network. And with this network, anyone with a disk can participate in, and it can help cut the IPC cost because the expensive block and log queries can be served from snapshots, so no archive nodes are actually needed behind each request. And also, this is also a preparation for PB scale. It means once the historical data reaches PB scale, there will be no single commercial SSD can host it, and no single operators can economically host it. That says the federation is not optional at that scale. So this is a full picture of this federated history network. There are 3 layers. At the top is producer layer. As you can see, all the clients can contribute to the network with their own way of exploiting historical data. Like Aragon has SSGRA, and Nimbus and GAS has their own binaries. And what comes out is the ERA1 file, which are byte deterministic across all these clients. And in the middle is a network. It's a BitTorrent B2B network coordinated by chain Toml v2, which replaces a centralized chain Toml v1 version that Aragon is currently using. In this network, any peer can verify what it downloads, and it can seed to others. That means there's no central authorities. And at the bottom is a consumer layer. Like once you can pull some like ERA1 files from the network, you're able to bootstrap a new native archive node, and you can also serve read-only IPC through the SS2 IPC binaries. And my EPF work lives on the consumer side of this diagram. So let's zoom in. This is a detailed flow on snapshot layer, basically align, convert, and serve. You can start with a ERA1 file. It can come from the network, and it will flow through the ERA2 SS binary, which will convert will convert the headers and bodies and transactions into epoch rounded segments and indexes. And also the receipts will become domain files and also log indexes. The difference is due to the Aragon defines receipts as part of the state files, so it's not epoch rounded. It's actually related to the state, and it's divided by the step. Then the last step is SS2 IPC binary. It will read those converted files and serve JSON IPC calls directly without EVM and StateDB. So this brings me to the 3 deliverables. D1 is segment epoch rounding. Because today Aragon segment files are aligned to like 500,000 block chunks, I'm going to align them to match the epoch size, which is 8,192. And once the boundaries match, the ERA1 file and segments conversion become bijective. So there will be no record splitting and no boundary handling. Then D2 is ERA to SS binary. This is a cross-client converter. Like we need to check the output of the converter if the output segments are byte equal to what Aragon produced natively right now. And D3 is SS2 IPC binary. This is a block-only IPC layer, roughly 12 methods, including ETH get blocks, which is the highest QPS method, and also the one that costs the most. Actually, there are more to be implemented in Aragon, but on 12 is in this scope to make sure I can finish this with the CPF. Okay, then this is a roadmap. Basically, each deliverables unlocks the next. Like without epoch rounding, the D2 gets messy, and without D2, D3 has no data sources to rely on. And if I if I'm able to finish ahead of the schedule, I will take some tasks from distribution layer. It's more related to the network, and also maybe try to implement more opposite methods. So yeah, that's all for this presentation. Thank you.
Thank you, Stephen. Awesome. Yeah, very well. Another very important project, folks. Do you have any thoughts, any questions about this? Yeah, I'm very excited to see this because we lost the portal network efforts, and currently the history is not being served properly through any decentralized means. And yeah, maybe one question would be whether there was any after I give you the feedback, like whether there any discussion about like using Starks to verify the integrity of the history or something like that. Like, do you think we can? It's maybe broader than the proposal itself, but can we somehow integrate the Stark proofs to have a easily verifiable history as well?
Yeah. I already talked to Aragon team, and yeah, right now the problem is that the post verification. Right now we're doing post verification. Basically, we're trying to like verify against the beacon state, but we cannot just do pre verification before downloading the file from the torrent network. Yeah, and we all believe that Stark is a very good way, but right now it's too heavy for us. So I think they are going to decide a more conservative way, which is to rely on another like consensus system. It's not it's not about POS consensus. They're going to build a like a committee, and each member of committee will hold a public key, something like that. So they are going to maintain the consensus. And in the first phase, we're going to rely on this kind of consensus. But I think I believe in the future we're going to shift this consensus to just like Polar Network to rely on the beacon state.
Right. Yeah, that makes sense. Thank you, Stephen. Awesome. Yeah, just randomly came up the idea last week, so I wanted to. As you can see, it's an important project that people care about. So came up last week uh, to add a feature there. Cool. Any more thoughts, anyone? Otherwise, we would move on. Yeah, let's do one more presentation, I guess. And the very first one to I haven't seen you here, but yeah, Samir, are you ready to present?
Yeah, I'm ready to present.
Yeah, hey Samir. I'm sorry I didn't call you out earlier. I didn't see you in the call. Maybe I just missed it. But yeah, I posted a review for your project
Yeah,
just now. It looks good. Yeah.
Can I actually do this next week? Because after going through a couple of things, even my slides were like not much technical in nature.
Okay,
Being
cool.
very honest.
Yeah,
So
just
I'll
want
just
to
do
that.
nothing problem once.
Perfect. Cool. Okay, cool. Right. So yeah, there are some more people who are signed up, but I think might want to do next week because I didn't have a chance to review their work. Daniel is here. Perflogic. Yeah.
Yes, I'm here.
Yeah. Would you like to present?
Yeah, okay. We can present. Let me share my screen.
Awesome. Yeah. And do we have your colleagues here as well?
Can I get Hans and Tushin? Are you guys here?
Yeah, Tosin and
Yeah.
Han.
Yeah.
That's you. Awesome. Yeah, go ahead.
Yeah, okay. Sure. Can you guys see my screen? Oh, okay, it's here.
Yeah. See myself there. Yeah. Awesome. Yeah. Go ahead.
So, hello everyone. My name is Daniel, and today I will present our project, which is full compatibility and cross-client interoperability for RIM. And this project is mentored by Sharik on RIM. And on this project, we have three members. It's me, Hans, and Toshin. And now we will discuss about three parts. The first part is introduction about Fulu for you guys to understand what it is. And then we will discuss about the problem and our goal for this project. And the last one is our solution and phases to deal with the problem. And I will present the first part, which is introduce about Fulu, and Hans and Toshin, they will present about the problem and goal and solution and phases, respectively. So let's go to the introduction. So in Fulu specification, they has introduced PDAS as one of the biggest changes in consensus layer. So before I jump into the PDAS, in Ethereum, after applying the EIP 4844, they have introduced a new transaction, namely block transaction. So now every layer 2 rollups will store their transaction data on block transaction. And here you can see on the image, base network and Arbitrum will store their transaction data into block 1, 2, 3 here, and they will be associated to block and plus 3 on Ethereum. So now every node on Ethereum not only store the normal block data that we often see on the Etherscan, they also have to store the blocks data. So for simplicity, I will group all the blocks into a new type of block here, namely block. So once a proposer produce block on Ethereum, they also produce the block, and all the block will be stored by all validators in Ethereum. This is what happened before the full specs. And because every validator stores same data, it will create a really high data duplication. So full spec is for solving this issue by introducing PDAS. So now instead of storing full blocks, every node in Ethereum will store only column. So we can see here. So now the block will be applied eraser code to create extended block here. I will talk more detail about it later on. And this coded block will be divided into multiple columns. And now they will be broadcasted into Gossip protocol, and every node in Ethereum, instead of storing full block here, they store only the data column, their assigned data columns. And this will reduce the data duplication. So the eraser code here is for making sure when some of the data is missing, the full block can be fully recovered. So let's look at the big picture. The block will be divided into multiple columns. Here we have 4 columns, and those will be applied to eraser code to create 4 more parts, the yellow ones here. So now we have 8 columns. And when we mix like 2 columns here, the full block can be still recovered. So behind the scenes, every node in Ethereum will store data columns, and they will do sampling on the column to make sure that more than 99% of the data exists. And this will make sure that the block can always be recovered, because making sure 100 block exists is impossible. So actually, you guys can check more detail on this link. Actually, I used to write a blog on this. So next one, we will move to problems and goal. So in the first week, we all come to this project with the project name Minimal PDAS for RIM. But during our work, we found out a lot of problem in RIM Beacon, and we have found out those forum problems, and it is our motivation for this project, and it will be taken over by Hans.
Yeah, thank you. Can you hear me well? Okay, you can go to the next slide. The main problem is not that RIM has no PDAS code, and actually many low-level primitives are already implemented. The gap is that these primitives are not yet connected into real beacon client flow, like proposing block, propagating data columns, fork choice sampling, custody, and also interop testing. Yeah, we can next. And the first concrete gap is the proposal flow. RIM already has the full block data, the block blobs, and KGG proof. But the current flow only size and publish the beacon block. For PDAS, the proposal also needs to derive data column sidecar from the blobs and gossip them to the correct data column subnets. And the second gap is RIM checks data availability by looking at the column sidecar already stored locally. But in the network, block propagation can be faster than data column propagation. So a valid block may arrive before its data. If we reject it immediately, we can drop useful blocks and even drop later blocks built on top of them, and the missing logic is a pending block pipeline. And the third gap is the node model. RIM currently behaves more like a super node. Every node store or 128 data columns, but PDAS is designed around custody nodes, where each node sample and custody only a subset of data. This requires more than changing the storage. The node must subscribe to the right data column subnets and serve only its custody columns, and actively fetch missing column by block root. Also, the sampling and reconstruction workflow is not wide end-to-end yet. For example, like the recover matrix exists, but it's currently unused, and the reconstructed sidecars are not served back to the network. And the last gap is testing and validation our work. Even if individual function pass unit test, PDAS compatibility is an end-to-end property. So RIM needs beacon client end-to-end tests to verify the full workflow, proposal, data column gossips, fork choice, and data availability checks. It also needs kurtosis integration for interop testing with other Ethereum clients. And without that, it is hard to prove that RIM can produce, receive, and validate PDAS data correctly in a real multi-client network. And at last, the project goal is making a RIM beacon client supporting full spec that can fully operate in mixed client network and can be used by validators on Ethereum network. And Tosin will continue this with the solution part. Thank you.
Well, thanks, guys. Yeah, so like we've stated, we intended working on the minimal DA clients. but we found out there were a couple of gaps that needed to be implemented to at least achieve full compatibility before we can actually work on the DA node itself. So we had to go through a couple of phases or an approach to kind of bring Ring first to full compatibility, at least to be spec compliant, before we can go on to the couple things and work on the DA node itself. So the first approach we took to this tool was to go through the spec and look out for the gaps that currently existed. We implemented the EF test itself, and we were using that as a metric to just judge our implementations to validate the whole thing. So just shown in the diagram is some of the gaps that currently existed and some of the components that we already implemented, right? And like Hans mentioned, we had is data available function implemented, but there were a couple of bugs. So through implementing this EF test, we caught some bugs and we were able to kind of get spec compliance initially. Yeah, next slide. So yeah, so we were able to easily achieve spec compliance, right? But we needed some kind of more robust way to kind of test what we've been doing, right? We needed to test for other behaviors itself, right? Including pairing and yeah, finalizing epoch and all that, right? So we worked on a test that we can easily include into the existing Beacon client CI, right? So we also went through other client implementation like Lighthouse and Prism, right? We referenced Lighthouse a lot because of the logic of the beacon chains harness, which was similar to what we implemented for our end-to-end test, right? So we use this to validate common behaviors among multiple RIM nodes that we are running within the CI itself. Yeah, so after this, we intend to also run, next slide, please. We intend to also run cross-client interoperability parallelly, right? Because this would also give us more insights to how RIM behaves with other clients, how it performs, yeah, just catch more bugs basically and implement and reiterate on things, right? So currently this has been quite a new phase because we didn't expect to work on we needed to work on the Cortosis integration itself, right? We had to go through existing implementations of the Starla code across other clients. We saw a couple of gaps that we existed within RIM that might be a blocker for that, but we were able to go through other implementations from clients. We saw how they handled the similar issues and we were able to go through with that. Similarly, we also explored other additional services that exist within Cortosis, right? Like Aceto, Dora, and Spammer. Like there are quite a couple of tools that can actually improve our whole test case itself. And yeah, so we are still deep into this phase, right? And I feel like we were able to catch more bugs and kind of bring RIM to much more stable phase in terms of like full compatibility itself. Yeah, so next slide. So yeah, so as Hans mentioned, there were a couple of issues, right, that happened that were with the is data available function itself, right? The current implementation just dropped blocks basically because the blobs are or the columns are not available yet. So we needed some kind of implementation to basically tackle this behavior. And the proposal by Daniel was working on this similar approach of what Lighthouse implemented, right? By checking for implementing some kind of way to keep blocks pending for a while to yeah, so we just check if the data is available. If it isn't, then we can keep it pending until a certain period of time before we can actually validate and move forward with it itself. So yeah, we intend to pick this up once we are done with the compliance itself. As Hans also mentioned, we are currently custodying all the 128 columns itself. So yeah, we intend to next slide. We intend to cut this down and implement the proper way. Yeah, I think we will also add the supernode as a feature within the flag, so you can both run as a supernode or you will run as with some custodian only some columns itself, right? Or you setting subnet itself. So yeah, so based on the spec compliance itself, we also go on to implement partial columns, right, and some other optimizations that exist, right, including peer scoring, which is one of the gaps that currently exist in our P2P interface implementation as well. So yeah, basically this will bring us to a very stable point, and we can easily decouple the DA client itself as a standalone, because most of those implementation is just working towards getting the DA client, and it should just be easily removed. Like we can easily separate it because most of the implementation is based off getting full compatibility itself, right? So yeah, I hope you guys enjoyed our presentation.
Yeah, thank you so much, guys. Love the animations. I will start with that. Yeah, very cool presentation. And it's also, I think, a great work on like dividing the roles and responsibilities here. Like three of you working on this and presenting together. It's great to see. Yeah, I think it's a really nice project. Folks, do we have any thoughts, any questions? Yeah, clapping. Thank you so much for the claps. It was a very nice presentation. Yeah.
Thank you.
Okay. If there are no questions, yeah. Yeah, thank you so much, Danielle. It's a nice one. I think that like people really enjoyed it. Seems like you had got the biggest applause here, but it's maybe also because we are gonna wrap up with this one then. Yeah, we've had many more people signed up to present, and again, like it's a bit of a mistake maybe to sign up before you finish the proposal and you get eager to present. Take some time to be able to get some feedback for um, next week. Yeah, I'm looking forward to that as well. I need to take some time to do the peer reviews properly. I got lost in reading all the proposals. It was a bit overwhelming. So I'm gonna continue that tomorrow, and I'll give you guys more feedback to work with. I hope you are gonna incorporate that and have more cool presentations next week. So once again, thank you so much for all the presentations today. I think we saw many great ones. Um, we've had many fellows presenting, so hopefully the next one might be the last, but we will see how much time it will take. So thank you so much, everyone, for joining us today, for presenting again. Many great presentations. Everyone who presented today did a really great job. I appreciate it, and I'm looking forward to see the execution and looking forward to see more of you next week. And yeah, awesome. Thank you so much, everyone. Indeed. Bye bye.